Hello everyone, welcome to my class. In today's class, I will start chapter 10, Parametric Equations and Polar Curves. Let me start the class right away. Quick overview. There are three ways to describe a curve in the plane. Using Cartesian coordinates, where we write the equations as y equals to function of x or x equals to function of y. Using parametric equations, that means we are writing x and y in terms of another parameter, the third parameter, say t, that is x equals to function of t and y equals to function of t. Polar coordinates, we write the equations in polar coordinate as x equals to function of r and theta and y equals to function of r and theta. That is x equals to r cosine theta and y equals to r sine theta. Great. So in these sections, I will cover parametric equations. So let me start. Parametric curves. Quick recall. Graphs that passes the vertical line test are graphs of functions. Some curve does not pass the vertical line test, then questions arise. Is there a way to represent such a curve as a graph of functions? So we can define a calculus on it later. The answer is yes. We use parametric equations. So let me give you the definition of parametric equations. We can define both x and y as a function of third variable t. We also call t as a parameter. So x equals to function of t and y equals to function of t. As t varies, the point xt, yt varies, then it traces out a curve called the parametric curve. Quick example. The parametric equations of a unit circle are x equals to cosine t and y equals to sine t. T lies between 0 to 2 pi. Quick visualizations. Sketch the circle. Let's make a t table here. So put t equals to the value between 0 and 2 pi and find the corresponding value for x and y and make a pair x and y and graph the order pair xy in the xy plane here. Great. So for example, t equals to 0, x equals to cosine 0, which is 1, y equals to sine 0, which is 0. So make order pair xy, which is 1, 0, and so on. And we have this circle here. Great. Now let's move on. Conversion formula means parametric equations to Cartesian equations, and from Cartesian equations to parametric equations, just eliminate the parameter t, going from parametric equations to the Cartesian equations. Quick ideas. Solve either one parametric equations for t and plug it into the other equations, or use trig identity if applicable. Let's do a quick example. Find the Cartesian equations for the unit circle, whose parametric equations are x equals to cosine t and y equals to sine t. T varies between 0 to 2 pi. Solutions. To eliminate the t, first square both sides and then add them. This gives us left side is x squared plus y squared. Right side is cosine squared t plus sine squared t. That's simply 1 using trig identity. So then we have x squared plus y squared equals to 1. That's the equation of unit circle in Cartesian form. Great. Now let's move on. Let's do some example. Example first. Describe and sketch the curve by using the parametric equations to plot points. Indicate with an arrow the direction in which the curve is traced as t increases. Also, find a Cartesian equation for the curve. So given curve is x equals to t squared minus 3 and y equals to t plus 2. T lies between -3 to 3. Awesome. Now let's begin the solutions. That's better. Let's make a t table. Put the value t equals to -3 to 3. So we pick t equals -3, t equals -1, t equals to 0, t equals to 1, t equals to 3, and we find the corresponding value for x and y. So let's say when t is -3, then -3 squared minus 3 is 9, minus 3 is 6, so x equals to 6. And for y, t equals to -3, so -3 plus 2 is -1, so y is -1. Make order pair x, y, so 6, comma, -1. I hope this makes sense to you all. Now, similarly, let's say put t equals to 0 here. Then t equals 0 gives us x equals to -3, which is here, and y equals to 2. So order pair is -3, comma 2, and so on. So we have this table. Now let's graph those xy point in xy plane here. On my diagram, let's say here, this point is 6, -1. So 1, 2, 3, 4, 5, 6, -1. I'm in the fourth quadrant. So this is 6, comma, -1, which corresponds to t equals to -3. And at t equals to 0, -3, 2. This is -1, 2, 3, -3, and 2, which corresponds to t equals to 0. And at t equals to +3, our point is 6, 5. So 6, 5 lies here. So we graph this curve. Great. Now let's move on. So the description, the graph is a parabola opening to the right. Now let's write in Cartesian equations. So let's try to eliminate the t from this given parametric equations. So then the idea is, by equation second, solve for t. So the second equation is y equals to t plus 2. So then subtract 2 from both sides, then t equals to y minus 2, and plug this value in equations 1. So now we have t equals to y minus 2. We plug back in equations 1. Awesome. Let's move on. Then from equation 1, x equals to t squared minus 3. X equals to, our t is y minus 2. So plug value t equals to y minus 2 square minus 3. Then FOIL y minus 2 is square, means multiply y minus 2 times y minus 2. It gives us y square minus 4y plus 4 minus 3 as it is. Now here's subtract 3 from 4. Then this gives us x equals to y square minus 4y plus 1, and our y between -1 to 5. So that comes from here. T equals to -3 to 3, then y equals to -1 to 5. Great. So let's move on. Let's do questions part B. That's better. Given question is x equals to sine t, y equals to 1 minus cosine t, t lies between 0 to 2 pi. So now let's begin the solutions. Make a t table. Here is a t, here is a x, here is a y column, here is a t column, here is a x column, here is a y column, and here is a point xy column. Pick t equals to values between 0 to 2 pi, including those endpoints as well. So we pick t equals to 0, pi half, pi, 3 pi over 2, 2 pi. And let's say when t is 0, our x is sine 0 is 0. Here, cosine 0 is 1, 1 minus 1 is 0, 0. So our point xy is simply origin. Similarly, let's say at a pi, we know the sine pi is 0. Cosine pi is -1. So negative times negative is positive. 1 plus 1, 2. So y is 2. So our point is 0, 2. And so on. So now we have this table. Now let's plot those points in xy plane. So 0, 0 lies here, 1, 1 lies here at t equals to pi half, and at t equals to pi, the point is 0, and 2, and so on. And again at 2 pi, our point is 0, 0. So we have this circle. Great. So the graph is a unit circle, center at 0, 1. Here is the center. Let's write its Cartesian equations. So from equations first, x equals to sine t, and from second, 1 minus y equals cosine t. We can simply square and add them. Let me scroll down. That's better. So then left side is x squared plus 1 minus y outside is square equals to, towards my right side, sine squared t plus cosine squared t. This is simply 1. That means now we do have this Cartesian equation of the circle. X squared plus y minus 1 outside is square equals to 1. Great. Now let's move on. Let's do example 2. Find a Cartesian equation of the curve, the given parametric equations, x equals to et, comma, y equals to e to the power negative 2t. In this case, the curve. Now begin the solutions. So here, let's eliminate t. So from second equation, so y equals to e to the power negative 2t, we can rewrite this as e to the power t to the power negative 2. I hope this makes sense to you all here. Then let's replace et by x. So x to the power negative 2, bring it down to the denominator, it becomes 1 over x squared. And we know x is not 0, so you can divide here because x is e to the t, and this cannot be negative or even 0. So then we have y equals to 1 over x squared. So we know this graph is simply this graph. And our x is not negative, so this lies only in the first quadrant. Awesome. Now, quick remark. The parametric equation of a Cartesian curve y equals to function of x is put x equals to t and then find y equals to ft. For example, the parametric equations of y equals to x squared minus 4 is x equals to put t, then y equals to t squared minus 4. So this 2 gives us the parametric equations of this given Cartesian equations. Awesome. So we finished these sections 10.1. Thank you.